Welcome to the lecture on application programming with SQL. For an application program written in a programming language such as Python, C, or Java, or any of the other modern programming languages, it must have access to several key functions. These are provided by libraries that the programmer adds to the application and then accesses those key functions by referencing the added library. The key functions are, first, to connect to a database; second, create a cursor to execute SQL statements using that connection; third, formulate a SQL statement based on user input; and fourth, execute that SQL statement in the cursor and retrieve the result set, and then finally loop through the result sets. We'll first look at two venerable approaches to providing these functions: Jdbc in Java and Odbc in .NET. So Jdbc is an application programming interface that allows a Java program to interact with a wide range of data sources. And it supports a variety of features for querying and updating data, and also supports metadata retrieval. With Jdbc, a company can leverage existing technology and personnel training, and it allows direct access to a database server, or you can access it through database middleware. It allows programmers to use their SQL skills to manipulate the data in the company's databases, and provides a way to connect to databases through an Odbc driver, connecting to the other large part of the application programming for databases world, Microsoft. So here again is the listing of basic functions we need to have our application in order to process database requests. We have to open a connection. We have to then create a statement object. We execute queries using the statement object and then fetch the results. And we then loop through the results. And obviously, we want an exception mechanism to handle errors. I used the Java Jdbc Oracle approach in this class 5 to 6 years ago, but the university computer science curriculum has changed, and Computer Science 201 and 202 are no longer Java, but C and Python. So we now use Python, and we will get to how we do that, how we do application programming in Python when we do our lab at the end of this lecture. But it's also instructive to see the same pattern of how we access databases in other approaches. And so we look at Jdbc and Odbc. So notice here, Jdbc, in the Jdbc code, the first step is we get the library, and in this case, it's a Java class that gives us our function, our needed functionality. So that's the class.forName and then oracle.jdbc driver. That gives us a driver to access Oracle databases inside a Java program using the Jdbc API. Next, we connect, and you can provide a user ID and password if needed. And that's in the connection class. Con is our particular instance, and we get connection, and then we give the Jdbc Oracle. And you see this is Yale, which is, of course, the author of the textbook is from Yale. And we have or we had at least 5 years ago, I was using it all the time. The same type of Java, Jdbc, Oracle database system at UMBC. So then we get a SQL statement structure, and that's in the statement object, statement class and the STMT object. And then in our work, we translate user desires into SQL queries. Here's an example of our work collecting data from the user and forming an insert statement and using the statement structure to execute it. Here's a different example of a select statement that we execute, a select query statement, and then we loop through the results. Notice that the SQL syntax, the select, from, group by, that is the same as we were using in a command shell. It's just here we're creating a string with that information, with that particular select statement, and then executing it in our statement structure that we have in Jdbc. So this is, in this slide, it shows how in Jdbc we can get specified field values and deal with nulls. And in the next few slides, it shows we can also get metadata like column names. So we can post column names when we give our results to the user who's using our program. And here's another example of getting the metadata that we might find helpful to provide to our users. I showed a transaction in SQL Server a few weeks ago, and just here you see how we can do the same thing in Oracle with Jdbc. Each vendor has its own approach to doing this. They have special languages that are used for stored procedures also that are kind of unique. PL SQL, very different. PL SQL for Oracle, very different than Transact SQL for Microsoft. So once we get beyond the traditional SQL that we might use in a command shell, that's where there's significant differences in the vendor's implementations. There's also special handling features for handling blobs and using streams. Database middleware like Odbc provides an interface between the application program and the database. It's part of what's known as universal data access. It's a collection of technologies used to access any type of data source and manage the data through a common interface. And it forms the backbone of Microsoft's database approach. And some of the terms you might have heard are Odbc, OLADB, and ADO.net. And throughout history, they've progressed from Odbc to OLADB to ADO.net. A lot of times, though, you'll hear people saying Odbc for the ADO.net connectivity, because it's kind of a continuum. So Microsoft's Open Database Connectivity, ODBC, is its implementation of a superset of SQL Access Group call level interface standards for database access. It's widely supported and used for database connectivity. And it's specifically for allowing Windows applications to access relational data sources by using SQL like we created the string, like we saw in Oracle, we create a string and we assign it to a statement object. Well, you do something similar in Odbc. The same set of functions are provided by Odbc drivers that we discussed at the beginning of the lecture and saw in the Java class for accessing Oracle. Again, you're going to have a connection to the database, and then you're going to have the options of providing a user ID and password. You're going to get a cursor that you can then use to send SQL commands and get SQL results. You can fetch the results using a particular command, SQL fetch, in which case you can then operate on them one at a time. And again, Microsoft, just like Oracle, provides metadata features where you can get column names and things of that nature, do transactions. And we saw the Microsoft SQL transaction format about a week and a half ago. And you have various levels of conformance where your program drivers comply with different levels of Odbc, Odbc level 2 being the more current in this set. So data access objects is an object-oriented API used to access Microsoft Access, Jdbc, and other databases from Visual Basic programs. It provides an optimized user interface that exposes the functionality in the JET database engine. So Microsoft Access is a relational database, but it uses a different database engine than Microsoft SQL Server. It uses what's known as the JET database engine. This is the database engine developed by Microsoft on its own prior to its acquisition of Sybase SQL Server that became Microsoft SQL Server, and prior to its access of FoxPro and their database technologies. There's also remote data objects. It's a higher level object-oriented application interface used to access remote database servers. And Microsoft implements Odbc, DAO, and RDO that is dynamically linked to applications through dynamic link libraries. ActiveX data objects, ADO, provides a high-level application-oriented interface to interact with OLADB, RDO, and DAO. So it's a unified method to access data from any of the database offerings from Microsoft. FoxPro, DBase 2 is what FoxPro is based on, Jet Engine, and the SQL Server. So ActiveX data objects, ADO, is a more comprehensive umbrella than Odbc, but it's very similar in its concepts. Embedded SQL was the approach used in COBOL with the first relational databases, DB2 and Oracle. And that goes back a while. A preprocessor would read the exec SQL statements and add in the DLLs with the needed functionality to handle those particular SQL exec statements. And here's an example of that old approach, and this is dating back 30 to 40 years ago. And again, it was widely used in COBOL programs. We used it quite a lot. And it was very efficient. And it kind of died away when C and Java and some of the more modern programming languages pushed COBOL aside in the late 80s and 90s. So even with the embedded SQL, that same pattern of functions was needed and provided. You open a connection, you fetch your results, you loop through them, and so on. And here we also obviously have to close the connection. So in our upcoming hands-on, we'll see how to do these functions in the Python programming language. Very straightforward to do them. Next, we'll continue with this lecture, though, and go forward with some more advanced SQL topics like procedures and triggers. So within SQL itself, we have the ability to create callable functions, and this ability is called stored procedures. And a stored procedure is a named collection of procedural and SQL statements. And it has several advantages. It reduces the network traffic because this is not going to be sending data back and forth in a series of actions between the client and the server. You call the procedure on the server, the work is done on the server, and only the end results of several actions are sent one time. And it obviously has the other advantage that is true of all functions or procedures. It reduces code duplication by means of code isolation and code sharing. So a SQL function is a named group of procedural and SQL statements that returns a value. And that's as indicated by a return statement in its program code, and can be invoked only within stored procedures or triggers. So we'll go over some examples in the next slides. Here it will create a function that accepts a parameter department and then returns results for that department. And we see that here in this slide. The equivalent, if we were just going to type this over and over and over again, is we would do the select department name from department where the department count for this particular department is greater than 12. But if we pass in a parameter, then we don't have to continually change. We can just do it one time and then call it with the department that we are interested in. And it can return a table, and you define the table it's going to return, and then you can also define it via a select statement as well. And the usage is, you would just say select star from table instructors of music, and instructors of is a function, and then music is the department parameter we just looked at, and it returns an intermediate table, and that's what is used in the rest of the query. And they can be invoked from a SQL procedure or from embedded SQL. You can also get repetition and selection capabilities in the procedural language. Keep in mind that the procedural languages that extend SQL are different for different vendors. Microsoft has Transact SQL. There's a 300-page book on the ins and outs of Transact SQL. Likewise, Oracle has PL SQL. And again, there's a lengthy book on PL SQL for using it. They're different. When you get to this level of procedural language, that it's really a pretty big extension of standard SQL, that's where the vendors become very proprietary. When you get your job, the particular database where you work will have the specified procedural language, be it Transact, PL, or whatever it would happen to be. Okay, and let's finish up talking about triggers. A trigger is procedural SQL code that's automatically invoked by the database management system when a particular data manipulation event occurs. The parts of the trigger definition are the triggering timing, indicating when the trigger's code executes. And again, these are written in like PL SQL for Oracle or Transact SQL for Microsoft. And again, they are very different in their syntax. The triggering event is a statement that causes the trigger to execute. And then the triggering level, is it at the statement level or is it at the row level? And then the triggering action, it could be PL SQL code or Transact SQL code enclosed between the begin and end keywords. So here's an example of creating one. And remember, the book uses Oracle for these type of extensions. And this continues what have been defined as a trigger. So the event that triggers the trigger can be an insert, delete, or update operation. And then you can use this extended language to do things like make sure that the balance doesn't go below 20,000. Although you could also do that with a check constraint. Or you can do a lot of things with triggers, but over time, the SQL standard has incorporated many of the things you might want to do inside of standard SQL. Like I just gave the example of a check constraint. Now it's getting to the point where the triggers are kind of an old functionality that enabled programmers to extend their ability in things that SQL didn't cover. But now there's better ways to do many of these things. And we can just think of, like a check constraint as being one of them. A couple examples of triggers that might be set. So again, sorry about that. Let me get back here. Okay. Okay, so yeah, triggers were an old functionality. Again, they enabled programmers in the old days to really extend their ability to do things that the SQL standard back in '92 or before just didn't cover. There are better ways to do many of these things today, as we see in this slide. Example, replication is now built in. And again, replication is a highly critical function today. And we'll cover more of this when we get into the NoSQL database section a little bit later in the course. Okay, so let's now close out this lecture and begin the hands-on, which is Python SQLite programming. Thank you.